Morning, everybody. Thank you so much for joining us on day 2 of the CalFlexHub Symposium. I'm going to talk a little about what we're going to cover today and a little about what we covered yesterday. But I want to start by thanking the Momentum team and Zoom for working on the operations and run of show for us. That was Kula Addy, who just introduced me, and Kula's done a great job helping our teams get organized. We've had Anna Yee backstage also and helping introduce the sessions. Scott Cox helping with the organization, and Alex Bonson is actually a Zoom employee that's helping with this Zoom platform. So I want to thank them. I also want to thank everybody for joining. We had over 230 people yesterday in the event. And the goal of this event is to get information out about what we're doing, why we're doing it, and what the opportunities are. So we're excited to share with you a little about today's event, and I'll walk you through the agenda. After my opening statements, you're going to hear a keynote from Ram Naranyanamurthy. I'll introduce him in a few minutes, but Ram is with the Department of Energy, and we're really excited to have him. He'll be talking about grid interactive efficient buildings and the relationship between that activity at the U.S. Department of Energy. Good news is Ram has been working in California for many years, so he's been a great partner with us to make the connections. After Ram, you're going to hear the CalFlexHub project showcase about commercial building technologies. Yesterday we heard about residential, small commercial, multifamily, and water heating. And today we'll be talking about commercial buildings, and there's a lot of new exciting technology in the commercial building sector. Then we'll take a short break, and you're going to hear a keynote from Alice Reynolds. And Alice is the president of the Public Utilities Commission. And when we think about CalFlexHub, it's really important for us to understand what's happening within California with our two key regulatory agencies that we interact with on energy efficiency and load flexibility. We heard yesterday from Commissioner Andrew McAllister, and he reviewed the load management standards, the concept of MIDAS, and the building codes and such, and what we're doing to try to advance the use of load flexibility. There are similar, very important activities at the Public Utilities Commission. The Public Utilities Commission has a new regulatory proceeding about using dynamic tariffs to enable more load flexibility. And one of the things that's interesting about those tariffs is how you reflect the system conditions. In fact, at SoCal Edison, at PG&E, and at other organizations, there's a lot of interest in making sure you're considering what's happening with the distribution system and trying to include local information about prices. So you may have a congestion problem in one part of the grid and really looking for some load shifting that's happening locally. Creating those prices is very challenging. And that's an important activity in our regulatory organizations and partnering with utilities to move towards prices that reflect system conditions. Those prices reflect information about the availability of energy and the greenhouse gases. And so we're in a really exciting time. I also want to talk about a few pieces of CalFlexHub that are not featured in these 2 days, but that are important parts of our portfolio that we'll be producing webinars in the future. One is what's called valuation. And so when we think about the technologies that we heard about yesterday and we're going to hear about today, how do we value them? There's one set of value to the stakeholders themselves, the utility bill players. We want to make sure that we're minimizing bills, customer bills. That influences what customers are willing to, technology they're willing to put into their building and allowing this load flexibility. We also think about the utility value, the grid value, and the societal value. For example, reducing greenhouse gases has tremendous societal value. And as mentioned yesterday, we talked a lot about equity and the need to enable load flexibility in those communities. We're also studying usability. We spoke yesterday, Therese Peffer mentioned the idea that smart devices may have dumb interfaces. Does the consumer need to know what's happening? And there are different opinions on how much they need to know and how much they engage. Mostly we want to support the idea of set and forget so that we can set a device to be price responsive. You may set a thermostat to say at one price, let's say when the price of electricity gets to 15 cents or 20 cents, I want to run my building another way. But if it gets to be more expensive, I'm willing to increase the deadband or let the temperature float up or float down, depending on if it's winter or summer. So we want to enable these action shapes, which Tristan mentioned yesterday. That is where that information is on how price gets translated into some sort of action. So this usability concept is an explicit part of our research. What do people think when they have these devices in their homes? What's their experience? Do they understand how that fan is helping with comfort? Or do they understand the mode that their water heater is in or their pool pump? So we have a lot of challenges in terms of getting these technologies to be usable. Now, if you're with a large facility, they have a professional facility manager. But we also need to think about the usability for those. We have homeowners, multifamily, small commercial. A small commercial building owner may not have a lot of information about their ability to interact with these devices as well. So I mentioned some of that, and I sort of went off on a tangent when I talked about the PUC and all the things we're doing. But let me get back to the rest of today's agenda. After the keynote from Alice Reynolds, we have a really exciting utility panel. Emily Nichols from Momentum is going to be moderating a session with Denver Hines from SMUD, Mark Martinez from SoCal Edison, and Albert Chu from PG&E. And those three people in the utilities in California are leaders in thinking about how to enable flexible load and what their utilities are doing to set the stage for these technologies to be scaled and deployed. Then we're going to have a breakout room. Marco Bertoni, Bruce Nordman, Jingjing Liu, and Amy Dryden will be putting that together. And those breakout rooms give you a chance to talk about things you've heard. They could be from today or from yesterday. So we're really excited about those breakout rooms. And we really enjoy getting the opportunity to hear from you about questions that you have and things that we're doing in CalFlexHub. The bottom line is we're very eager to have a stakeholder engagement activity to make sure that we're thinking about the businesses and thinking about the different customers, stakeholders, aggregators, utilities, NGOs and equity community organizations, and thinking about the pathways to enable this technology to be deployed at scale and to be cost effective and affordable. I'm going to make a couple of other comments about yesterday's activities. As I mentioned a moment ago, we heard from Andrew McAllister, who introduced things that the California Energy Commission is doing to enable flexible load to be of value to the state of California. And when we think about flexible load, we're moving from a time when demand response was designed for the top 200 to 250 hours, mostly hot summer afternoons, to a 24/7 load flexibility concept. That is a very new thing, and you don't see that in many places in California, in the United States, or around the world. And one of the key things we want to do is enable the ability to use prices to get that 8760 or 24/7 response. So Commissioner McAllister gave us an introduction into the MIDAS, the Market Informed Demand Automation Server. I want to also acknowledge Olivine, a partner in CalFlexHub. Olivine has been working with the CEC and with utilities to develop price server communication platforms. And we have a research price server where we're developing shapes. Tristan showed a few of those shapes yesterday. Those shapes reflect the shape of the cost of electricity on the grid at different times of the year. And CalFlexHub is using these proxy shapes to send that information to a device, which is different from today's tariffs. So we're developing a winter shape, a spring shape, a summer shape, and looking at how those devices go to some control system and create the platform for those action shapes that Tristan mentioned, whether that's in the cloud, locally in a gateway. And there's 3 ways that devices can consume these prices. One is through a third-party cloud that takes the information on prices and translates it into something that the device is going to respond to that's simplified, so that information may be in the cloud. Another way is straight to the device. For example, those CTA water heaters, Tristan gave the example of some of the water heaters being able to have that information locally. So third-party cloud, straight to a device, or as Bruce mentioned in some of the discussions, into some sort of gateway. And I think that was in one of our breakouts, so not everybody heard this. But if there's a device in a building or a home where the price signal comes to that device and then it's distributed through the house or through the building, so that a device, maybe your EV, a battery, a thermal storage system, a smart thermostat, a heat pump water heater, are getting that price from a central entity of some sort or a gateway. Now, Daniel Gerber alluded to that when he was talking about some of the smart panels, where the smart panel is tracking the price of electricity and the power level of the home and trying to explore which devices need to be flexible to enable the electricity capacity of that home to be optimized and price responsive. So we have some historic data on how those devices are used and control among those. So those are some pathways that we're thinking about for CalFlexHub and prices to devices. So I'm going to stop now and introduce Ram Naranyanamurthy. If we can go to the next slide. I'm really excited to have Ram join us on the CalFlexHub stage today. Ram is a program director of emerging technologies, but I'd also like to say he's recently become the deputy director of the Building Technology Office at the Department of Energy. In that capacity, he'll be overseeing a large portfolio of research related to buildings, emerging technologies, residential and commercial, building codes, load flexibility, and he has an excellent background that allows him to be knowledgeable of the current state of practice and where things are headed. He's got a background with the Electric Power Research Institute, where he spent many years working on decarbonization of buildings. And he's got experience with a variety of solutions in affordable housing. He's got extensive background with the California Energy Commission, working with New York. And he was the chief science officer at EcoFirst, where he worked on home energy management systems, integrating photovoltaics and solar thermal. He's got 27 patents, so he's got a lot of experience with a background in engineering from Penn State and from the Indian Institute of Technology. So let me join Ram, and thank you, Ram, for joining us today. We're looking forward to your remarks.
Thank you, Marianne, and just good morning to all the attendees, and if you're on the East Coast, good afternoon. So thank you again, and thanks for the invite. Happy to discuss and dive into this really critical and important topic, right? So within the DOE, I just wanted to focus on, many of you have heard about this initiative, the GAB initiative, or the Grid Integrated Efficient Buildings Initiative. Connected communities is a big topic recently. And I wanted to thank Marianne and LBL for their leadership and support in both of these big initiatives. So as we talk about it, if you can go to the next slide, Kula. So when we think about from a big picture perspective, what are we trying to do, right? We are trying to reduce our greenhouse gas emissions. We are trying to decarbonize our power system, and at the same time, trying to do it in an equitable way, right? So as we look at all these different goals, they are aligned, but they also need individual actions on each of these areas. So next slide, Kula. So when we think about buildings, right, and this is our perspective from the buildings office, between the direct and the indirect emissions, buildings are the largest contributor to GHG emissions in the US. Yes, we have a significant amount of fossil fuel combustion that leads to direct emissions from buildings. But we also have to remember that buildings are using about 75% of the electricity generated. And so the emissions that are generated in power generation also come back to the building stock. So work that we do in our buildings, energy efficiency, really also impacts emissions from the power sector. And I also don't want to just forget about the fact that the refrigerants and the fluorinated gases, if you look at this, it means that the refrigerants are actually about 20% of direct emissions from buildings. So some of the work that CARB is doing in terms of refrigerant phase outs and the work that we do in the refrigerant area with moving to low GWP refrigerants is actually a critical part of the research that we do in the building sector. Next slide, please. So how do we look at the contribution of buildings to our decarbonization at BTO, right? So one is, of course, we have to reduce our fossil fuel fired demand through electrification. That's a big area of research and implementation. We also have to remember that that there's also methane leakage from gas pipelines that might also add to the direct emissions from buildings. Now, what we also have to remember, though, is that buildings serve a purpose. Buildings provide shelter, they provide security, they provide a functionality, they provide, they have significant impact on health outcomes. So we have to remember that there is a core purpose to buildings. And then what we want to do is serve that core purpose while doing it energy efficiently, and then go to the societal benefits such as decarbonization and grid integration. So we have to make sure that we are serving the core purpose and then applying the energy efficiency and then applying decarbonization to buildings. Next slide, please. So when we think about it, right? So this whole strategy, right, is look at buildings as people-centric, creating healthy, comfortable, resilient buildings for living and working, right? Then we do other initiatives such as reducing the energy cost burden. That's a huge issue, right? We know that energy prices have gone up. We know that people are going to have trouble with their bills. I think the estimate is 20 million households in the US are behind on their bills. So what do we do about affordability? What do we do about efficiency? Then we look at equipment efficiency. Then we look at electrification. We look at demand management, and demand management contributes to the clean grid. And then ultimately looking at things like embodied carbon, low GWP refrigerant. So there's a whole spectrum of the work that we have to do within the buildings office. Now, when we think about the other aspect of buildings, which is buildings are also where the grid ends. So work that we do with the buildings is very critical to this transition to a low carbon grid. So we have to keep all those things in mind. Next slide, please. So this is a vision for where we want to get to by net zero for the net zero US economy by 2050. Big picture goals, of course, increase building efficiency. We have to really drive reduction on-site energy use because that is what reduces customer energy burdens. Yes, we can talk about electrification, but without efficiency, we're not going to be able to reduce customer energy burden. So it's very critical that we focus on efficiency. Accelerate electrification. Right now, if you look at electrification, it's actually a very regionalized challenge in the US. California, the Midwest, the Northeast, that's where most of the fossil fuel fired equipment goes into. So how do you actually make that transition, but also make the transition in a cost-effective manner, right? And then third, how do we transform the grid edge? As we drive efficiency, as we drive electrification, as we electrify our buildings and our vehicles, right? Everything lands right at the edge of the buildings. So how do we transform the grid edge so that we are not replacing transformers all over the state, right? We are not digging out direct buried cable and retrenching wiring. Can we do that, right? How does building flexibility and demand flexibility help us in that transformation of the grid edge? So that's going to be a key focus for the buildings office as we go forward. And ultimately, if we can achieve these goals, right, then what it means is that we focus our work on affordable housing, on low-income communities, disadvantaged communities, ensure that a significant amount of benefits flow there. So this whole concept of let us rethink how we approach this decarbonization transition, starting from disadvantaged communities, looking at technologies that serve them, and then see how that translates to the larger market. We have to significantly drive down cost of decarbonizing building segments. Right now, estimates are somewhere around $20,000, $30,000, $40,000 per home to decarbonize a home, to electrify and decarbonize. So how do we actually substantially cut down the cost of that decarbonization using both technology advances as well as incentives, rebates, and programmatic interventions? And finally, we know that climate adaptation is going to be key. So how do we actually increase the ability of communities to withstand that, withstand all the change that's happening? So that's where resiliency comes in. Resiliency is not just about putting a battery on a building. Resiliency is about getting better building envelopes, better windows, having more distributed storage, thermal storage, battery storage. How do all of these resiliency elements work together to improve customer resiliency? We have to think that we are going from 3 fuel sources to 1 as we do the electrification. So that's all. And flexibility also plays a role in the resiliency. So this is the whole area around transforming the grid edge. So that's going to be a big focus for us. We are going to be working on the national roadmap that LBL published, and we are looking at how these changes around decarbonization impact grid interactive efficient buildings, this whole grid edge issue, right? So the other big initiative that we have, Connected Communities, I'll talk a little bit more about it. It's a series of 10 projects around the country, large-scale demonstrations that are looking at this integration of EVs, PV, microgrids, demand flexibility, flexible devices, as well as looking at how efficiency and integrative retrofits can help us reduce the demand on our power grid. Next slide. So these are just, I'll dive a little bit into this whole topic of connected communities, mainly because this is actually a great microcosm of all the work that we're doing around demand flexibility. So it's a series of 10 projects around the country. They cover multiple building types, campuses like Ohio State. We're working on affordable multifamily, Seattle, New York, Boston, working on single family communities. The one project in California is in Southern California and Menifee, working with Southern California Edison, and also large commercial buildings in Madison, Wisconsin, and then also another experiment around transactive energy and how rates can help with flexibility that's being conducted in the Northeast. Next slide. So just a few examples, right? So this project is one that's led by Edo Energy in collaboration with Avista, which is a utility in Spokane. And in this case, Avista is looking at how demand flexibility can be integrated into the distribution management systems. So in this case, they're trying to look at avoiding things like substation buildouts so that we can actually use the demand flexibility, use efficiency. Couple of these buildings, these are large commercial buildings where they've been able to eliminate gas hookups for boilers by using thermal storage, using the flexibility from thermal storage, adding battery storage, and then demand flexibility from the building loads themselves, the HVAC loads, to be able to aggregate that, represent that at the ADMS, DMS, distribution management system level, so that the utilities can actually look at demand flexibility as a resource in their distribution system. Next slide, please. This is the other example. This is residential, and this one is, of course, in Southern California. So it's 2 communities being built by KB Homes. One of the communities will have batteries in the homes and being aggregated. The other community is looking at a community microgrid. So looking at resiliency for customers in 2 different ways. What works, what doesn't work, what are the regulatory barriers, as, for example, around community microgrids. This project is also going to be evaluating 2-way V2G and two-way EV charging as a potential for avoiding stationary storage, as a potential to add demand flexibility from buildings and new construction. So in a sense, this is like taking where we have gone to with the Title 24 with the net zero code, implementing the net zero code, going beyond that, looking at customer resilience, looking at two-way EV charging, looking at microgrids to see how net zero communities can go above and beyond in terms of providing demand flexibility and customer resilience. Next slide, please. Another example, this is Portland General over in North Portland, where they are looking at recruiting around 3,000 residential customers and looking to aggregate residential loads, similar to what CalFlexHub is also working on. So we are trying to connect all of these pieces together, and LBL, of course, through Marianne's organization, is kind of the glue that holds all of these together. So in this case, looking at 1.4 megawatts of flexible loads through retrofitting affordable housing, single-family homes, things like smart thermostats, water heaters, advanced vehicle charging. So all of this will be, again, integrated into Portland General's DER management systems and advanced distribution systems. And then NREL's working on how do you optimize these connected loads for multiple grid services. So these are all just examples of how the DOE is looking at this whole integration at the grid edge of different resources. How do they provide flexibility? How do we enable decarbonization? How do we enable electrification so that we can move towards that decarbonized future? Next slide. And this is my last slide. And I will stop here. So we talked about some of the examples of how we are looking at flexibility, how we are approaching the systems integration issues. Now, going back, I think one of the biggest challenges that we are really looking at and worried about is this whole sequencing. How do you sequence affordability, decarbonization, and flexibility? Customer energy costs are a big concern. This is a chart that some of the research at LBL has put together, and it kind of shows the carbon savings and the cost savings. One of the challenges that we see is that many states, especially California, we have a challenge with consumer economics with electrification of buildings. How do we address that, right? If you see the top right, which is where you have both cost savings and carbon savings, those are many warm weather states, the Southeast, Texas, etc. So what is different between California and Texas? Electric grids. One of the things that we really want to look at is how do we actually reflect the cost of the electric system into the rates so that we can support electrification. So things like more fixed rates, less variability in rates supports electrification. A lower variable component of electric rates supports electrification. And that is a slightly different context. And that's something that I think we really have to think about, right? How do we improve affordability while decarbonizing, right? More weatherization, more energy efficient equipment, right? We have to really look at how do we apply those so that we can decarbonize while still keeping customer affordability in mind. Another thing that wanted to just put out there is some of the more successful utility rate programs around affordable housing are things like the SRP Salt River Project's fixed bill program. I think there is a need to provide insurance, need to provide certainty around energy bills for customers, and so that's something that we'll have to keep in mind. So how do we actually combine that affordability and electrification that might be more reflective of the fact that most of the electric system costs are on the wires, that more than half the costs are on the wires, which kind of goes towards more of a fixed cost structure, with the need to still promote flexibility. So something to think about. I think it's great that we are testing so many different rate programs. I think PG&E is looking at some of these rates that might promote electrification. Things like critical peak pricing, maybe that's another option, but something to think about as we look into the future and as we try to promote both electrification and flexibility. that there might be something that things that we'll have to look at in terms of customer affordability, cost effectiveness, and rates. So with that, I will pause and stop. Thank you, everyone. Thanks for the time.
Thank you, Ram. And thank you all for joining the opening session in Keynote. Our first project showcase of day 2 begins now. You'll want to click into the session titled Project Showcase Commercial Building Technologies, and you'll be able to view now. Enjoy.